Okay, guys, for this part of the lesson, let's go ahead and solve some equations. So remember, we're going to undo the operations and we're going to undo them in the opposite of order of operations. So what is happening to x, the variable? It has been multiplied and then subtracted. So we're going to undo the subtraction by addition, and then we're going to undo multiplication by division. So remember, whatever we do to one side of the equation, we must do to the other. So we're going to add 12 to both sides, keeping it balanced. Bring down your 3 times x. And remember, your goal is to isolate x to see what the solution is. Remember, the solution is the value that's going to make the left side equal the right side. So we undid multiplication by division, and our solution is 12. So if I plug in 12 for x, and now apply the order of operations, we're going to multiply, and then we're going to subtract, and we get that true statement verifying that our solution, x equals 12, is correct. Now for this equation, we have some value that's being divided by 4, and then we're adding 7 to that. So we're going to undo the addition by subtraction, and we're going to subtract on both sides to keep it balanced. When we subtract 7, we're making the positive 7 go to 0. Now we're going to undo division by multiplication. So we're going to multiply both sides by the 4. These 4's cancel. We have isolated x, and our solution is x equals 12. If we were to plug 12 back in for x and apply the order of operations, we will get a true statement. 12 divided by 4 is 3. When we add 7 to the 3, we get 10 equals 10. Okay, let's try a few more. This time x is being multiplied by -2 and adding 8. We're going to subtract 8 from both sides. We're going to bring down -2 times x. We're going to undo multiplication by dividing by that coefficient -2 on both sides. We've isolated x, and we get x equals -24. So our one solution is -24. On this problem, we have some number being divided by -3, subtracting 9. We're going to undo the subtraction first because we're always going to work backward when solving. We're going to undo division by multiplication. The -3's cancel, and my one solution is -33. Okay, this time these problems, our unknown variable, our unknown value, x, is on the right side. So you're always going to work from the perspective of the x. So x is being multiplied, and then we're adding 4. So we're going to undo that addition by subtraction. And again, we're isolating x. We're going to undo multiplication by division. And my x value is 2. In this problem, some numbers being divided by 2, and then we're subtracting 7. So we're trying to isolate x, so we're trying to get rid of the -7 first, and then the division, the divide by 2. So we're going to add 7 to both sides. We're going to undo division by multiplication. So these 2's cancel, leaving me with x equals 20. I just always like to put my x on the left side when I'm finished. So my one solution is x equals 20. 20 is the only value that if we plug in will make a true statement. Okay, so let's go over a few things. The equations we've done up to now have been simple two-step equations, but sometimes we need to simplify the equation. And what I mean by simplify is if we have parentheses, we need to apply the distributive property first. So if there's parentheses in your equation, you always need to apply the distributive property. The next thing you need to check for is combine like terms on either side. So if there's terms that are alike, we need to combine those. Then number 3, if we have variables on the left and variables on the right, we need to get those together before we actually start solving the equation. And my rule of thumb is to move the smallest variable. So let's write this problem down and go through each of these checklists. So I notice we have parentheses. So we have to use the distributive property, which just says to multiply the coefficient of 2 times everything in the parentheses. So 2 times x is 2x. 2 times positive 1 is positive 2. On this side of the equation, I notice that I have two constants, so we can put negative 7 and negative 3 together. So we have a 4x, and this is minus 10. So we've gone through 1 and 2, and the third one says if we have variables on both sides of the equation, we need to get them either on the left or the right. So 2x is smaller than 4x, so we need to remove 2x, and we do that by using the inverse operation. So if I have 2x and I take away 2x, I no longer have any x's on the left side. Bring down your 2 equals 4x minus 2x is 2x minus 10. Okay, I'm going to come up here, and now we're going to solve it. I'm going to go ahead and just switch around and put the 2x minus 10 on the left and equals 2 on the right. You do not have to, but I like. Now we are just solving a two-step equation. This is where we're actually solving. Up to this point, we're just simplifying. So we have 2 times x minus 10. So we're going to add 10 to both sides. We have 2 times x equals 12. We're going to get rid of multiplication by division. And my one solution is 6. So again, if you have any of these things in your equation, we need to check them off in this order and then start solving. So let's take a look at a few of these problems. In this problem, we have parentheses, so we always have to start by applying the distributive property to get rid of the parentheses. So 2 times minus 6 is minus 12. Now we can solve. We don't have variables on either side. We don't have variables or like terms to combine, so we're going to add 12 to both sides. We're going to undo multiplication by dividing both sides by 2. And my isolated variable is x equals 10. That's my solution. In this problem, we have parentheses on the right side, so I'm going to distribute the coefficient of negative 3. Now we have multiplication and subtraction to undo. So again, we're isolating x, so we're going to remove the minus 6 by adding 6 to both sides. Then we have negative 3 times x. We want to undo multiplication by dividing. We divide both sides by that negative 3. My one solution is x equals negative 8. Okay, in this problem, there's no parentheses, but I do have some like terms that can combine. So notice how I include the operation in front of the term. So this is 4x minus 2x, so that's really 2x minus 6 on the left. We don't have variables on the left or right, so we can solve now. We have multiplication and subtraction, so we're going to undo subtraction first by the addition property, adding 6 to both sides. We're going to undo multiplication by dividing by the 2. And my isolated variable x is equal to 12, my one solution. In this problem, we do not have parentheses, but we do have two constants that can be combined. So I have 3x, and then positive 2 minus 9 is minus 7. Now we have multiplication and subtraction. Again, we're isolating x, which is on the right side. So we're going to add 7 to both sides of the equation. We're going to undo multiplication by dividing. And my solution is x equals 5. It is the only value that will make this equation a true statement, meaning the left side equals the right side. Okay, in this example, there's no parentheses, there's no like terms to combine, but I do have x's on the left and x's on the right. We need to get those either on the left side or the right side. I always like to get rid of the smaller variable. So I'm going to get rid of the 6x on the left by subtracting. So I have to also subtract it on the right to keep it balanced. I bring down the positive 8. Now I just have a two-step equation to solve. We're going to add 14 to both sides. We're going to undo the multiplication by dividing, and my one solution is x equals 11. In this problem, we have a 3x on the left and a positive 1x on the right. I'm going to subtract 1x from both sides. We have 2x minus 6 equals, this is a positive 8. Always notice the operation. So we are going to undo multiplication and subtracting. So we're going to add 6 to both sides, and we have 2 times x is equal to 14. We're going to divide both sides by the positive 2, and our one solution is 7. It is the only value that will make this equation true when I plug in 7 on the left for x and 7 on the right. Okay. So in this problem, we have parentheses, we have variables on the left and the right, so we have to distribute first. We have to dissolve our parentheses. So we get 3x plus 9 equals 1x minus 12. Again, we have variables on the left and the right. 1 is smaller than 3, so I'm going to subtract the 1x. We get 2x plus 9 is equal to negative 12. We're going to add 9 to both sides. We get 2 times x is equal to negative 3. We're going to divide both sides by 2, and notice this time our x value is going to be a fraction, negative 3 halves. You can write this as negative 1.5 if you want, but I prefer just leaving our fractions like this. So it's okay if our value is a fraction. In this problem, we need to first distribute the 2. So we're going to multiply 2 times x and 2 times 8. We have variables on the left and the right. So negative 4x is smaller than positive 2x, so we need to make negative 4x become 0. So we're going to add the opposite. And if we add on the left, we have to add on the right. Notice that this 6 is a negative 6. We're isolating x, so we're going to undo the addition by subtracting. We're going to undo multiplication by division. And again, we're going to have a fraction. That is okay. It's going to be negative. Now, we can leave it improper, but I know I can reduce it by a factor of 2 because they're both even numbers. So 2 can go into 2211 and 2 can go into 63, and it is negative. So that's our one solution. Okay, let's try a couple more. These seem a bit complex, like what we started with when we were simplifying and solving. So we have parentheses. So let's apply the distributive property. So we get negative 2x, and then a negative times a negative is positive 2. On this side, I'm going to go ahead and combine like terms. 2x plus 1x is 3x. We have variables on the left, variables on the right. Negative 2x is smaller than 3x, so I'm going to make negative 2x go to 0, by adding 2x to both sides. So negative 2x plus 2x is 0. This is a positive 2 I'm going to bring down. 3x plus 2x is 5x. We're isolating x, so we're going to get rid of the minus 3 first. We get 5 is equal to 5 times x. We're going to undo multiplication by dividing. And my solution is x equals 1. In this problem, we need to get rid of the parentheses. This is a -1, so we're going to distribute the negative to everything in the parentheses. On the left, we can combine -1x and -5x. That's going to be -6x minus 2 equals 6 minus 4x. Now we have variables on the left and variables on the right. -6x is smaller than -4x, so I'm going to apply the addition property. So this will become nothing, and we're going to add the 6x to the right side. We're going to bring down -2. Always look to see what's in front of your number, your term, and then we get 6 plus 2x. -4x plus 6x is 2x. Now, x is being multiplied, and then we're adding a positive 6. So we're going to get rid of the 6 first. So I'm going to subtract 6. We get -8 is equal to 2. -8 equals 2x. We're going to undo multiplication by dividing. And my one solution is x equals -4. So these two were pretty complex, but just take it one at a time. Remember to apply the distributive property first if you have parentheses. Then you're going to combine like terms, like we did here and here. And then third, you're going to get variables on, if you have variables on both sides, you're going to get them to either on the left or the right. And again, let's move the smaller one.